Algebra, Lesson 5-4, Point-Slope Form of a Linear Equation. Please make sure you have your note packets out and that you are taking good notes. Today our objectives are to write a linear equation in point-slope form. We're also going to be graphing a linear equation in point-slope form. So here's what point-slope form looks like. Y minus y sub 1 equals m times x minus x sub 1. Where does this formula come from? Well, it comes from the formula for slope, where you notice our change in x is in our denominator, our change in y is in our numerator, and this rise over run is what gives us m. So if I treat this as a proportion and I cross multiply, I get y2 minus y1 times 1 equals m times x2 minus x1. And now this looks exactly like point-slope form, except we don't have a 2, we just have a y sub 1. But that's where this formula is coming from, our formula for slope. So let's use it today. The key concepts are point-slope form contains an actual slope and a point in it. So it is useful in graphing because you can pull out a slope and you can pull out a point. So in question number 1, our objective is to write a linear equation in point-slope form. Well, these are already written for us, so we're going to be taking out the slope and figuring out what the point is on that line. So looking at our formula, our m is 2/3, so m is equal to 2 over 3. And now the point that we're pulling out, we're subtracting an x value, so we're subtracting 4. But over here, it looks like we're adding 2. So that really means we're subtracting a negative 2. So because it says plus 2, that's actually a negative 2 in there. So if I were to rewrite this original question, it would say y minus a minus 2 equals 2/3 times x minus 4. So the numbers, the m is the slope, our x value, we're subtracting a positive 4, and here we're subtracting a negative 2. So it's very important. In the equation, we have subtraction. So when we pull the numbers out, they become the opposite. So a negative 4 or subtracting 4 became a positive 4. Adding 2 became a negative 2 in our answer. Let's try another one, number 2. My slope is a half. And now we're going to pick out our point. So we're subtracting our x value, so it looks like we're pulling out a 3. And our y value is also going to be 3. Please pause the video, and why don't you guys try 3 and 4 on your own. Number 3, my slope is 1/4. I want to subtract my x value, so this looks like x minus a minus 2. So my x value is negative 2. And over here, this would be y minus a minus 5. So again, I have to pull out a negative 5. So if the signs show plus, when you pull them out, they will become positive, because the original formula shows subtraction. Number 4, if I rewrite this equation, I get y minus 0 equals 2 times x minus a minus 3. So my slope is the 0. I pull out a negative 3 for my x and 0 for my y. So to use point-slope form, you must have a slope and a point. Please turn the page. The next objective is going to be us writing equation in slope-intercept form. So what we're going to do is use our formula to rewrite this equation. So this is going to be my x1. 5 is going to be my y1, and m is my m. So I get y minus 5 equals negative 5 times x minus 2. So in the pink positions, I plugged in a 2 and a 5, so we subtract 5 and we subtract 2, and the yellow position becomes negative 5. My answer needs to be y equals mx plus b, so I need to solve for y. My first step is going to be to distribute. So I get negative 5x plus 10, because a negative times a negative would be negative positive 10. And then I'm going to add 5 to get y alone. So my ending answer is y equals negative 5x plus 15. Let's try another one. Here's my x1, my y1, and my m. So I have y minus a minus 6, which turns into plus. 2 for my slope. X minus a minus 4 turns into plus. Our goal is to get y by itself. So again, we're going to distribute the 2. So I get 2x plus 8. Get rid of my 6. And there's our answer. Our ending answer for question number 1 is y equals x minus 5. In question number 2, we're going to put it in point-slope form, and then we're going to solve it for y to get it into slope-intercept form. So again, when I put the 8 in, it becomes positive. When I put the 7 in, it becomes negative because of our signs in the original equation. Distribute the 3. And subtract 8. In these last two questions, I'm going to have you put them in point-slope form and stop. Do not go all the way to slope-intercept form. So here are my answers. Number 3, y minus 4 equals 9 times the quantity x plus 2. So just looking at this, I can tell my slope is 9, and my point would be negative 2, 4. And I could graph that. Number 4 could be simplified from where I'm at. This is really y. And then over here, you could either leave it, but if you distribute it, you just get y equals 3x. So on question number 4, if the directions just said write an equation in point-slope form, I would accept either answer. We are going to jump ahead 3 slides. So 1, 2, 3, and then we're going to end up here. So this is on page 24 of your note packet. The next objective we're going to cover is graphing a linear equation in point-slope form. What is the graph of this equation? Step 1. Graph the point that is within the equation. Think opposite. The reason why it says think opposite is because, remember, when you pull these numbers out, you need to do the opposite sign. So the point that is in this equation is 4, 2. So if I plot that point, that means I'm going forward 4 and up 2. Now I need to find the slope, and that is given to me within the equation. So my slope is 2/3, or -2 over -3. So I am going to go up 2, forward 3. And if I do that again, I'll be off my graph. So I'm going to go down 2, backwards 3. So repeat that a couple of times. Remember, you need a minimum of 3 points on your graph. And then go ahead and make a line and connect your dots. So this would be what the equation of the line would look like when we graph it. So let's try that again. So question number 1, let's pull out the slope. Again, here's that formula. So the slope is 1/4. And if we pull out the point, we get 2, -1. If you want to graph your point first, 2, -1, and then apply your slope. Now I can't go forward anymore, so I have to use my other slope, which is equivalent to -1 over -4. So that means I would go down 1, backwards 4. And then again, remember to connect your dots and draw your arrowheads. Try number 2 on your own. Please pause the video while the students work. On the second example, my point is -4, +4. So now when I apply the slope, I'm going to go down 3, forward 1. Down 3, forward 1. And again, draw your line. So point-slope form is helpful when we are graphing. Please pause the video while the students work on the final 2 questions. Number 3, the point that we pull out is 3, -5. And our slope is -1/3. So I found my point 3, -5 first, and then I went up 1, backwards 3. So I did 1, -3. In number 4, I pulled up my point and I got -3, +2. My slope was 5/1 or -5 over -1. I did need to use both of those slopes. So my first starting point was here, -3, 2. So then I went up 5, forward 1, or down 5, back 1. This concludes lesson 4 of chapter 5.